our problem here is we're trying to solve the equation sine of 2 theta minus cosine of theta equals 0 over the interval from 0 to 2 pi. So I've plotted both of those functions on the graph from 0 to 2 pi. And we're going to look at where sine of 2 theta is equal to cosine of theta. So I just moved cosine to the other side of the equation. So if sine of 2 theta is equal to cosine of theta, then their graphs will intersect. And so we have 4 intersections here. We've got, get the marker out. We've got the first one there, another one here, third there, and last but not least, there. So I'm going to start today by focusing on the intersections that happen at 0, because those should be easier to calculate. So we know from memorization, basically, that cosine of theta is equal to 0 on the vertical axis, where x equals 0 on our unit circle. And so cosine equals 0 at pi over 2 and 3 pi over 2. We know that sine of theta equals 0 at 0 and 2 pi, and also at pi, where y equals 0. So we can say from that here, when our function cosine of theta first equals 0, that's going to be at pi over 2. And we can check and see that at sine of twice pi over 2 at pi, sine is equal to 0. So our first answer is pi over 2. So next we want to find this other intersection, and that's the other place where cosine is equal to 0 at 3 pi over 2. And we can double check. 3 pi over 2 times 2 is 3 pi, which is the same as pi in this sinusoid world. And we see that we've marked that sine of pi is equal to 0. So there's our second answer, 3 pi over 2. So the next two are a little bit more tricky. I'm going to make an educated guess that these are going to lie on special triangles. So I'm going to say that our first triangle that I'm going to try is at pi over 6. So a 30, 60, 90 triangle. And the reason I chose pi over 6 instead of pi over 4 is because I know that for pi over 4, the two values of sine and cosine are already equal. So if you multiply the angle by 2, they would then not be equal. So for pi over 6, I know that the value of cosine is adjacent over hypotenuse. And if this is a 1, 2, root 3 triangle, that would be square root of 3 over 2. And now I'm going to try twice that angle. So pi over 3. This is another 30, 60, 90 triangle. And if we have 1, 2, square root of 3 at pi over 3, you can see that the sine, the opposite over the hypotenuse, is also square root of 3 over 2. So there's our next answer. I'm going to type in here pi over 6. And for our final solution, I can see that it happens before the cosine reaches its minimum. And I'm going to guess that it's another 30, 60, 90 triangle. So I'm going to come in and say it's at 5/6. So 5 pi over 6. And then that makes doubling that 5 pi over 3, which is, we have 3/3 here, and then 2 more thirds would get us to here. Another 30, 60, 90 triangle. And you can see that the x value for the cosine matches the y value for the sine. So our next answer is 5 pi over 6. And there you have all the 4 answers for the equation sine of 2 theta minus cosine of theta equals 0 on the interval from 0 to 2 pi.